So the three major domains from which you can expect questions from pharmaceutical analysis are spectroscopy, titrations, and chromatography. Okay, इससे ही questions आएंगे. From this only the questions are going to come up. Okay. So now in the titrations, we have different types of titrations, right? What are those major types of titrations that we have covered? Acid base, redox. Acid base is commonly called as the neutralization titration as well. Okay, redox. Then we have covered the precipitation, non-aqueous, and complexometry. Correct? The major 5 categories of titration that you must cover. Now, when we talk about the redox, redox is also further classified into different kinds of titrations. What are those? Iodometry, iodimetry, bromatometry, permanganometry, seriometry, dichrometry. Right? These are the major domains from which you can expect questions to pop up in your examinations. So ये ही कहीं से आएंगे क्वेश्चन. अब कैसे आएंगे? What kind of questions will be asked? आइए देखते हैं. So mostly they will ask questions on the indicators. Okay, which indicator is used in which kind of titrations? So they can ask on type as well as the color change. So if they ask phenolphthalein, so phenolphthalein is useful in acid-base titration. When will it change its color from colorless to pink? When the pH is about 10 or 8.3 to 11, the range. So that is a measure. The color change and the type. Suppose if they ask you eriochrome. So eriochrome is a kind of a metallochromic indicator. It's useful in complexometry titration. If they ask you crystal violet, it's a kind of a indicator useful in the non-aqueous titration. Okay. If they ask you diphenylamine, fluorescein, they are useful in Fajan's method of titration, which is precipitation titration. So different kinds of titration have different categories of indicators. So there are internal indicators, there are self indicators. So steric ammonium sulfate and your KMNO4, they are examples of the self indicators. Then you have the external indicators like starch iodide paper. So there are different kinds of indicators that they ask. Then they might ask on the graphs. So in the aqueous as in the acid-base titrations, there is a strong acid versus strong base, strong acid versus weak base, weak acid versus strong base, and weak acid against weak base. The 4 types. So based on that, they can ask you questions कि भाई कौन से type of titration में कौन से shape का graph आता है, in which it is sigmoid, in which it is parabolic. Okay, so it will revolve around these particular topics only in your titrations. Okay, and the solvent, especially in non-aqueous titrations, because we have protogenic, protophilic, amphiprotic, aprotic, different kinds of solvents that are being employed for those kind of titrations. So solvent पे they might ask you questions. इसके बाहर question नहीं जाएगा. Everything will be inside this only. Chromatography. So we have studied about the different types of chromatography techniques, right? What are the different kinds of chromatography techniques? Ion exchange, size exclusion, and size exclusion is also called as gel permeation or gel filtration chromatography. Affinity chromatography, in which we have a affinity between a protein, a ligand and a receptor, enzyme and a substrate. So, affinity chromatography. Then we have high performance liquid chromatography, HPLC. Then we have TLC, thin layer chromatography, paper chromatography. So TLC is an adsorption chromatography. Paper is a partition chromatography. Correct? HPTLC, which is an automated version of TLC, high performance thin layer chromatography. Okay. Then we have gas chromatography. Now, they are again divided, further divided into different kind of categories. Like GC is divided into GSC and GLC. Gas solid chromatography, gas liquid chromatography, right? So there are different categories into which a particular chromatography is divided. So what are the basic questions that you can expect from the chromatography part? You can expect questions that will pop up from either principal adsorption है, partition है, on the Van Diemen's plot, which is an HPLC. You can expect questions from the detectors. So in GC, you have thermal conductivity detector, flame ionization detector, electroconductivity detectors, injecting system. So you have a rheodine injecting system in HPLC, split and splitless injecting system in your GC column. So they will be asking you questions C8, C18 column, which one is used in normal phase, which one is used in reverse phase chromatography techniques. What is a what WCOT columns? It's useful in GC, right? So mostly you can expect questions. Then carrier gas, temperature programming in GC, all of these questions. They are very common questions that are being asked. Okay. So इसके बाहर question नहीं जाएंगे. Types of ion exchangers. So you have cationic and anionic, and they are further divided into strong cationic, weak cationic, strong anionic, and weak anionic. What is an ion exchange capacity? These are all PYQs, and let me tell you, concepts do repeat. So please make sure that you do have a very strong, firm, and a grip over all of these topics. ये छोड़ना तो बिल्कुल भी नहीं. ये छोड़ दिया तो आप 4 मार्क डोनेट करके आएंगे NBMS को. And at Academically, we believe that you must be prepared 360 degrees. पूरा कहीं से भी क्वेश्चन आ जाए तुम्हारे उसको सॉल्व करने की क्षमता कम नहीं होनी चाहिए. Then up we have spectroscopy. So when I speak about spectroscopy, we have UV visible spectroscopy, we have IR spectroscopy, we have NMR, we have mass. We have covered all of these topics as well. We have fluorescence, we have atomic absorption, we have flame emission spectroscopy. We have nepheloturbidometry. Okay. Sir, ये तो अपने स्पेक्ट्रोस्कोपी के नाम लिखे. How do we know what kind of questions we have to prepare? सबर करो. Okay. So for this, mostly you have to prepare commonly. Sir, commonly matlab kya? The table that we have made at Academically, right? I have to made one table with your sources. UV kaha to hydrogen, deuterium, mercury, tungsten, xenon. IR bola to nurst, globar, globar. NMR bola, mass bola to electron gun, radio frequency oscillator, right? Source, detectors. UV bola to photomultiplier tube. IR bola to bolometer and Golay cell. Yes, mass bola to Maldi-Toff. So these are the different detectors. Then some miscellaneous points, जैसे UV में electronic shifts, electronic transitions. So I've told you bathochromic shift, hypsochromic shift, transition में sigma to sigma star into sigma star, Woodward-Fischer rule. Correct? Then principles. Each spectroscopy is based upon a particular principle. Like UV visible is based upon the principle of Beer-Lambert's law. IR is based upon the principle of Hooke's law. Okay. In the miscellaneous point in mass, you can include McLafferty's rearrangement. In IR, you can include the vibrations, bending and stretching. That is the most common. उससे तो आप हर साल आता ही और एक साल छोड़ के एक साल तो आता ही आता. So that we cannot leave. We cannot leave that part. So sources, detectors, principles, certain miscellaneous points. These are the 4 domains from which in spectroscopy you can expect questions. In spectroscopy, you can expect questions from these 4. But in fluorescence, you can expect from Jablon Sky's diagram. Correct? तो ये तो छोड़ के जाना ही नहीं. Monochromators, grating, prisms, all of those. Next up, you have the last point, electroanalytical method that we are going to cover today. And I'll just give you a free glimpse about it and then we'll continue in detail about it. So when you talk about electroanalytical method, we have conductometry, polarography, and potentiometry. What did I say? We have conductometry, potentiometry, polarography. And also you have thermal methods in which you have thermogravimetry analysis, differential scanning calorimetry, DSC, and TGA. Conductometry, potentiometry, polarography. ओके सर अब ये तो आपने सिर्फ नाम लिख दिया इसमें पढ़ना क्या है जस्ट द एप्लीकेशंस that they are useful for estimation of what are they useful for polymorphism are they useful for thermal conductivity and we'll discuss that in detail ahead. Okay, polarography mein you can study about the Alkovic's equation, what is Nernst potential in potentiometry you can study because इस पे previous years पे there have been questions and let me tell you if you want to qualify GPAT it needs smart work as well as the analysis of the previous year papers. So you need to know about this that you have to have a balance between both of them. Correct? Nernst potential. So ये आपका one pager chart. This is like your handout, one page handout that you need to know for pharmaceutical analysis. Similarly, I have prepared one handout for ecology also. When I completed pharmacology for y'all, I have made a similar layout. So if after analysis I've made this layout for you, please make sure you study this. And from tomorrow we'll be starting biochemistry as well. So biochemistry का भी हम ऐसे ही एक layout बना देंगे and after that biotechnology. So for that as well. So please make sure that for all these four subjects, at least for me, you must know all of these topics that I have listed down. And in 28 days, aram se these topics can be covered. If you have paid attention to the lectures, if you have paid attention to what I've spoken, to what I've made you all write, then this will be a cakewalk for you. Okay? Done, done. Have we all written all of this and have we all understood? You can take a screenshot of this or later on you can watch through the recording as well. Right? It will be available for you. Done? Chalo. Now let's start with the remaining part of the titrations that we just left with the Karl Fischer titration. So yeah, in the Karl Fischer titration, it's their favorite. मतलब वो पूछते हैं either उसके primary standard पे, the reagent पे or the principal पे. So you must have a thorough idea about the Karl Fischer titration. You must have a thorough idea about the Karl Fischer titrations. Right? Yesterday we also did about the diazotization titration, which is nothing but nitrite titration. So Karl Fischer, it is basically used to estimate the moisture and the water content. And what is it based upon? It is based upon the oxidation reaction between iodine and sulfur dioxide, GPAT 2017. In this, iodine gets converted to iodide, and that iodine leads to formation of sulfur trioxide, GPAT 2018. Karl Fischer reagent, GPAT 2021, iodine, sulfur dioxide, methanol, dry methanol to be very specific. Let me write it dry methanol solvent, and imidazole, which acts as a buffer. GPAT 2014, formula for water content determination using. So S is a volume of the volume in ml of the reagent which is consumed, and F is the water per ml of that reagent. Divided by the milligram of sample or the test preparation that you are using. So whatever I've marked here is a question. What is the primary standard used in Karl Fischer? Sodium tartarate dihydrate. You must know about all of these points which have been listed here. Please take a minute but write all of these points. Done, 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 done. Now it can be done via two techniques. Either you can use volumetry or you can use colorimetry. Colorimetry is an electrochemical technique only. Okay. Volumetric, which is suitable for water content which is up to 1%, and the other is colorimetry. What is the source of iodine? So oxidation of iodide gives you iodine. Oxidation of iodide gives you iodine. Simple. Karl Fischer में बस इतने ही points याद रखने हैं. If you want to know how do you perform Karl Fischer, what is a piston burette, what is a nozzle, sorry, you don't have time right now. You need to focus only upon these important points. If you want to study in detail later on, we can discuss it, of course. But right now, you just need to focus upon the points that have been marked. They are of utmost importance. Next up, we have thermal analysis. So in this, there was a question in GPAT 2023, thermogravimetry analysis, and in NIPER 2023 on differential thermal analysis. What is measured in the differential scanning calorimetry? The heat absorbed or released during heating and cooling. And it is useful for the heat capacity, glass transition. So many polymers, they have a glass transition temperature, TG. You call it as TG, glass transition temperature. So most of the polymeric solutions in pharmaceutics, Sohail sir would have taught you about the polymeric solutions, right? Polymers. So you have entry-core polymers, you have colon targeted polymers, you have film forming polymers, biodegradable polymers. So they have a particular glass transition temperature. So that can be measured using the differential scanning colorimetry. In differential thermal analysis, temperature changes. Here it was heat. Heat. Here it is temperature. समझ रहे हो? Are you understanding the difference? Heat and over here temperature. It is useful to study the oxidation, decomposition, the loss of water. Thermogravimetry analysis. Weight. Change in the weight. Change in the heat, change in the temperature, change in the weight. Again for melting point and glass transition temperature. Thermomechanical is not important, you can leave it. Just these three. कृपया इसे लिख लिया जाए. कृपया इसे अपनी कॉपियों में लिख लिया जाए. We must write them down. क्लियर है? चलो आगे बढ़ेंगे. This is the principle of how a constant temperature and how a variable temperature. So thermogravimetry analysis, the substance is heated or cooled at a particular rate. And then you estimate its weight, TGA. So at constant temperature, weight is plotted against time. While at constant variable temperature, weight is plotted against the temperature. Weight तो constant ही है भाई. Weight तो दोनों में ही x axis पे आएगा. But if the temperature is variable, we will use on the y axis temperature as a legend. And if it is a x axis pe, then we will use time. On the weight, if it is a constant temperature, then on the y axis you will use time. So you can have two plots, weight against time if it's constant temperature, weight against temperature if it is a variable temperature. है ना, because temperature change हो रहा है तो अलग अलग temperature पे अलग अलग weight होगा. Suppose this is 20 degree, this is 30 degree, this is 40 degree. तो तीनों टेम्परेचर अलग अलग है ना, तो अलग अलग वेट होगा. तो इस पे अगर वेरिएबल टेम्परेचर है तो तुम्हें अलग अलग वेट का अलग अलग टेम्परेचर के अगेंस्ट प्लॉट करना पड़ेगा. बट ऑन द अदर हैंड टेम्परेचर सेम है तो क्या फर्क पड़ता है, 30 डिग्री पे ही तो आ रहा है सारा. बट टाइम पॉइंट्स 5 मिनट पे 30 डिग्री पे कितना वेट आया, 10 मिनट पे 30 डिग्री पे कितना वेट आया, 20 मिनट्स पे 30 डिग्री पे कितना वेट आया. That is how you plot for constant temperature. So these are the two comparative charts that you need to keep in mind for the TGA. Correct? You must write these down. So there are three types of TGA, not to be studied in detail. GPAT में कभी नहीं पूछा है, but it is only for your knowledge. Isothermal, constant temperature. Quasi-static, constant weight. Dynamic, where there is a linear change of the temperature. Where there is a linear change of the temperature. Isothermal मतलब constant temperature. Dynamic मतलब linear change in the temperature. Quasi-static मतलब constant weight in the series. And this is called as a thermograph. Just so you had chromatograph. Correct? Chromatography में the graph was chromatogram. वैसे thermogravimetry में the graph is thermograph. The graph is thermograph. Applications. So it is useful in the characterization of materials. Study the degradation mechanisms, because many of times when we perform the degradation studies, stability studies, accelerated condition studies, we need to identify whether the substance is being affected by the changes in the temperature, changes in the time, changes in the weight. So we perform the degradation mechanism studies as well. Determination of organic and inorganic content, because you are analyzing the sample. The rest are not that important. The first three are very, very important applications. You must write them. Then up you have differential thermal analysis, where there is a technique of recording the temperature change. So you have temperature sensors, furnace whereby the heating occurs, temperature change between a reference sample and your substance, your test substance and the reference sample. You need to record the temperature change between both of them. So differential thermal analysis, it has a DTA curve. It forms two peaks, endothermic and exothermic. What peaks does it form? इस पे एक बार क्वेश्चन आया था, peaks पे. Endothermic and exothermic peaks. Endothermic peaks मतलब कि dehydration. Exothermic peaks मतलब कि crystallization. Simple. Endothermic peaks मतलब dehydration. Exothermic peaks मतलब कि crystallization. Clear है? Is this clear to us?